Good afternoon, everyone. In my presentation, I will talk about an estimation of the predicted environmental concentration, the PEC, described before by Mathieu. This is the second part of the REACH methodology to assess the risk. So to estimate this concentration, we use the numerical modeling in the ECOCAP project. We've done this modeling over three different domains. The first one is the Seine Bay, into which the Courseulles-sur-Mer wind farm were considered. The second one is the northern part.
Nicolas,
yes.
We cannot see your slide. It's just stuck on your first one.
Okay, I will just try again. Sorry about that. Is it okay? Is it changing for you?
Yes.
Okay.
You can switch your, yes, perfect.
Okay. So as I was saying, the second domain is the northern part of the Bay of Biscay, which include the three wind farms. So the Saint-Nazaire wind farm over here, Yonneau-Armoutier wind farm, and the future floating wind farm of the Sud-Bretagne on the western part of the domain. And the third domain is the Gulf of Lion, which include the two future floating wind farm of the AO6, which would be on the following years. To estimate the predicted environmental concentration, I use the same methodology for the three domains. So I will just present you today the Gulf of Lion configuration. So to consider the release of the anode, so the dissolved anode and the release of aluminium coming from this, we have considered the two wind farms of the AO6, so positioned over here, and we considered their extension. So we have two wind farms of 750 megawatts, and we have considered that we have 15 megawatts turbines, so 50 turbines per wind farms. For each wind turbine, we have implanted 5 tons of aluminium, which lead us to a release of about 162 milligram every calculation time step of the model, which is every 10 seconds. So every 10 seconds, at each location of each wind turbines, we released 162 milligram of aluminium in the domain, which lead us to this variation of the total mass of aluminium. So if we look at this graph, we can see the evolution of the total mass of aluminium. We can look at only the purple one, which is the sum of the two wind farms. We can see the initial phase where the aluminium mass is rapidly increasing, and we can see that the variation is influenced by the seasonal variability. We can see that during the summer period, we have a huge decrease of the aluminium mass, so which means that the aluminium is evacuated outside of the domain, and followed by a part which is stable around the winter and fall. And during the spring, we can see a large increase occurring on the second year of the simulation. So this told us that the aluminium mass stays relatively stable across the years. So only a 2-year simulation is okay to understand which concentration could appear in the domain. Now, if we look at this concentration, the anode influence, we can see on the left part the average concentration on each part. So you can see every dot representing every wind turbines, and we can see the average concentration is very low in the domain during the 2 years, about 0.09 microgram per liter for the area 1 part on the west side, and 0.07 microgram per liters on the area 2. But we will look for the predicted environmental concentration. We considered the worst case scenario, so we look mainly on the maximum concentration that could occur during the 2 years. So we can see that these concentrations are higher. For the west part, so western area 1, we have 1.8 microgram per liters, but for the area 2, we have 1.5 microgram per liters. So we can see that the hydrodynamics is very important on these concentration and could really influence the impact of the anodes in the environment. So this picture represents the influence of the wind farms, but we know that in the environment they are not the only source of aluminium that could occur in the environment, and especially we have the rivers, which brings a lot of aluminium, because as you know, the aluminium is the third element, most abundant element in the Earth's crust. So naturally, the rivers will carry a lot of dissolved aluminium in their plume. So to consider the influence of the Rhône in the Gulf of Lion, we do not have enough data to perform a realistic variation during the 2 years. So what we have done here, we have gathered the maximum of in situ measurements of dissolved aluminium concentration in the Rhône plume, and we have performed a probability density function, which told us that the most probable situation is a concentration of 17.1 microgram per liter of aluminium released by the Rhône River. So to fill the missing data of a realistic variation, we have considered that the Rhône River in our simulation released a constant concentration of 17.1 microgram per liter during the 2 years. And we can see on the picture on the bottom right, the maximum concentration induced only by the Rhône River discharge. So there is no anode here, there is only the Rhône River. On this picture, we can see in the dilution area, we have concentration ranging from 10 to, of course, 17 microgram per liter inside the Rhône. But in the area 1 on the left part over here, so the wind farm, the Rhône River will induce a concentration of about 1 microgram per liter, while on the eastern area 2, we have a concentration of 4 microgram per liters. So we can see here that on the area 1, the influence of the Rhône River is similar to the anode, but on the area 2, it's almost 3 times higher than the anode naturally over this area. So we have considered the river now, but there are also different sources of aluminium, and especially in the Mediterranean Sea, we have the impact of atmospheric inputs. Schuh and Volas in 1997 have performed a lot of measurements in the western part of the Mediterranean Sea, and we can see the concentration they have measured range from 0.5 to 4 microgram per liters. So these most of these points were most of these measurements were performed away from the coast, so away from the influence of the rivers. And in their articles, they explain that most of these aluminium comes from the Sahara. So that when there's a sandstorm, a lot of sand come into the Mediterranean Sea and dissolve into the seawater and bring a lot of aluminium, which is counted by hundreds of tons every year. So we have included this impact of what we have called the ambient concentration, which is the other source of aluminium in our study. And to place this study into the worst case scenario, we have considered the maximum of ambient concentration, that is 4 microgram per liters, and we have put it as a constant around our numerical domain. So now we have our 3 different sources of aluminium, and if we combine them by simply addition, sum them, we have our PEC cumulated, which is the accumulation of every sources, and we can see here on the bottom right what are the different influences over the area, the wind farm areas. So for example, for area 1, we have the anode influence, 1.8 micrograms per liter, the river influence, the Rhône, 1 microgram per liter, and the 4 microgram per liter coming from the ambient concentration, which bring us to almost 7 microgram per liter for our PEC cumulated over the area 1. Over area 2, we can see the influence of the anode is minimal against the others, and we almost reached 10 microgram per liters when we cumulate everything. So this is for the Gulf of Lion, and as a conclusion, what we have seen in the ECOCAP project is that even if the anode bring some aluminium into the environment, that should be considered in the risk analysis, they are not the main source of aluminium in the different facades. You have also the PEC cumulated of the others here, and you can see that, for example, for the Seine Bay, most of the aluminium come from the Seine River itself, which is almost 2 times the influence of the anode. And in the northern part of the Bay of Biscay, the Loire is very important, has a very important influence on the aluminium concentration. You can see almost 21 microgram per liters over the Saint-Nazaire area, while the anode only brings 0.6 microgram per liters, because as you can see, as the sum here. So this is something that should be considered in the risk analysis, and Mathieu will present you this right after. And I thank you very much for your attention.